Hey there, hope you're having a wonderful day. So in the previous few videos, we went over how to create enemies, we implemented collision detection with the enemies, and we also created a health bar. So just to show you what we have so far, if I save and run the program, you can see we have 3 enemies. These are called metalls, and if Mega Man charges towards them, every second we collide with the enemy, the health bar goes down by 1. Okay? Now that we have all that created, the next thing we want to do is allow Mega Man to destroy these enemies. And in the Mega Man games, Mega Man does so by shooting bullets. So before we implement shooting bullets, the first thing I want to do is load all the images and change the sprite of Mega Man to show Mega Man shooting. So here you can see we have 4 sprites we need to implement. We have facing left, jump shooting, and facing left, standing and shooting, and facing right, jump shooting, and facing right, standing and shooting. And here we have the bullet, and we also have another bullet image, and this bullet is different, and that is because the metal enemy can also fire bullets at Mega Man. So for Mega Man, we will be using this bullet image. And basically, when Mega Man fires bullets, his arm turns into a cannon or a gun. So the first thing we'll do is implement the sprites, and then afterwards, we'll have Mega Man shoot bullets. Alright, like always, whenever we introduce new images, we need to scale them down. So here I'm going to add 2 more variables. So player underscore shoot width, and this will be 62. And we don't need a height variable, and that is because the height will be the same as player height, so 48 pixels. And then let's also do the same for player jump shoot. So player underscore jump underscore shoot underscore width, and this is going to be 58 pixels. And again, we don't need one for the height, and that is because it will use the same jump height value, so 60 pixels. Alright, so we have the variables down. Now let's load the images. So we have 4 images that we need to load. So over here, I'll do player underscore image shoot right, and we'll do load image. And the image name is megaman dash right dash shoot .png, and we need to specify the width and height of the image. So player shoot width and player height. And let's do the same for player image shoot left. So load image megaman dash left dash shoot .png, and the width and height will be the same as this. So let's just copy and paste this. Now we need to do the same for the jump and shooting images. So player underscore image jump shoot right load image, and the image name is megaman dash right jump shoot .png. And here I'm going to enter the width and height tuple on the next line so that you can see it. So it's going to be player underscore jump shoot width and player jump height. And I think I'll just copy and paste this for facing left. So for this, I'm going to change this to left, and for the file name, we're going to change this to left, and that's pretty much all we need. Alright, so we have the images. Now we need to change Mega Man to use the shooting position. So in our class, I'm going to add another field called shooting, and by default this is false. Alright, so we have shooting just like how we have jumping. So now I'm going to update this method, update image. So we need to account for 2 more scenarios that we are introducing, and that is shooting and jumping. So I'm going to make this elif, and I'm going to copy and paste this over here and change this to self.shooting, and we're going to change the image to player image shoot right, and for this one we're going to change it to player image shoot left. And then I'm going to paste one more time, and here we're going to do if self.jumping and self.shooting, and this will be player image jump shoot right, and this other one will be player image jump shoot left. So now we have 4 scenarios. Now what we need to do is add a click handler. So we need to listen for a key press, and when we do, I'm going to call a function. So set shooting, And here I'll just do self.shooting and set it to true. So let's scroll all the way down for where we handle key presses. And over here, I'm going to add another set of keys. So if keys Pygame, and I'll do .k_x. So if we press on the X key or keys Pygame.k_space, so this is the space key. So we can shoot by pressing on the space key or the X key. So if we press on either one, I'm going to do player.set_shooting. Alright, so just as a quick recap, if I press on the X key or the spacebar key, we're going to set shooting to true. And if shooting is true, then we're going to update image and use these images. And of course, if we're jumping at the same time, then we'll use these images, okay? So let's save and run the program. And let's see what we have here. So string object is not callable. Perhaps you missed a comma. Did I miss a comma? Let's see. So I'm going to scroll up, and yes, I did miss a comma. So we should add a comma here and a comma here. Alright, so let's save and run the program again. Alright, so I'm going to press on the X key, and you can see megaman is now in the shooting position. And I can face left and right. I can jump. So you can see the images are working properly. Alright, so now the next thing we need to do is fire bullets. Alright, so over here, let's add some variables for the bullet. So player_bullet width. This is going to be 16 pixels wide, and player_bullet height. This is going to be 12 pixels tall. And of course, the bullet needs to have a velocity so that it can move. So player_velocity x. Since we only shoot left and right, we don't have a velocity y. So over here, I'll just have velocity x. And I'll set it to 8. So whenever we fire a bullet, it's only going left or right, but never up. And it's going at a rate of 8 pixels per frame. Alright, so once we have these variables, let's load the bullet image. So over here, I'm going to do player_image_bullet. And we're going to load image bullet.png. And the width and height will be player bullet width and player bullet height. Alright, so we have the image. Now we need to create a class, specifically a rectangle class, to represent the bullet so that we can draw and move the bullet. And over here, I'm going to add the bullet class as a nested class. So this is basically a class within another class. So I can do class bullet, which inherits pygame.rect. And if you're not familiar with nested classes, basically, I'm only ever creating this bullet class inside this player class. So in a way, this player class owns the bullet class. And we'll also do the same with the metalls. So the metal class will have its own bullet class. That way, we can have two separate bullet classes to represent two different kinds of bullets. And if you want to know more about classes and nested classes, I have a tutorial on Python object-oriented programming on my YouTube channel, and I'll link it in the video description below. I definitely encourage you to check it out if you want to learn more about these object-oriented programming concepts, okay? So when we create the bullet, we need a constructor. And in the constructor, I'm going to create a rectangle just like I did here for our player. When we create the bullet, we actually need to take into account the direction that the player is facing in. And that is because of the X position. If the player is facing to the left, then we just take the X position of the player. But if the player is facing to the right, then we want the right side of the player. So the X position plus the player width. So here I'm going to make a check. If player.direction is equal to left, if that is the case, then I'll do pygame.rect._init, and we'll make the X position player.x, and the Y position will be player.y as well, except we want to shift it down. So here you can see we have megaman, and the X position and Y position is on the top left corner. So the X position will be over here. And for the Y position, we want to shift it down so that instead of starting the bullet from megaman's head, the bullet will start from megaman's arm cannon. And precisely, we want to shift it down by tile size divided by 2. So half the tile size will shift it down enough for the bullet to be over here. So here, I'm going to shift it down by tile size divided by 2, and the width and height will be player bullet width and player bullet height. And of course, we need to add a velocity. So here I'll do self.velocityx and set it to negative player bullet velocity x. And did I not name this correctly? So I'm going to scroll up, and okay, so we have a mistake here, and that is I reassign player velocity x. So this should be player underscore bullet underscore velocity x, okay? So it should not be the same name as this player velocity x. So make sure you fix this, and let's scroll back down. All right, so now we have this, and it is negative because we are going to the left, okay? And here I'll do elif player.direction is equal to right. We'll do pygame.rect.init self. And here, since the bullet is going to face to the right side, we want to create the bullet starting from the right side of megaman. So this will be player.x plus player.width. And then the y position will be the same. So player.y plus tile size divided by 2. And the width and height will be player bullet width and player bullet height. And of course, we need the velocity as well. So self.velocity x is going to be player bullet velocity x. So this is positive since it is going to the right. Lastly, we need the image. So self.image is going to be player image bullet. So we have our bullet class, and this will depend on whether megaman is facing to the left or right. Now, in our set shooting, I'm going to add this bullet. And before we can add the bullet, we need a list to store all the bullets, just like how we have a list of metalls or a list of tiles. So I'm going to scroll up over here, and I'll add self.bullets and set it to an empty list. And then let's scroll back down. Over here, we'll do self.bullets.append, and I want to create a new bullet object. So I'll do player, which is this class, dot bullet, which is the inner class or the nested class, and we don't have to pass in anything. So we create the bullet, and the bullet is now in the list. Now the next thing we need to do is draw and move the bullets. So let's move the bullets. So over here, I'm going to add for bullet in player dot bullets, bullet dot x plus equal bullet dot velocity x. So now the bullets will move each frame, and let's draw the bullets. So here I'll do for bullet in player.bullets, window.blit, bullet.image, and bullet. Let's save and run the program. And now I'm going to press on the X key, and you can see we fired a bunch of bullets. And actually, I can hold on to the key and go like this. And you can see we are firing a lot of bullets. Now, there's an issue with this, and that is we are creating way too many bullets. So what we can do is we can limit the number of bullets that can be fired. So basically, every time megaman fires a bullet, we need to have a cooldown period or a delay before megaman can fire another bullet. And we can do so by adding another custom event. In this case, I will call it shooting underscore end, and this will be pygame.userEvent plus 1. So we're going to do the same thing as we did for invincible. Basically, we're going to shoot the bullet, and then we're going to call this event after a certain delay, which will set shooting back to false. So similar to what we did here. So here you can see we set invincible to true, and then we have a timer to create an event, which we will listen for. So here I'll do pygame.time.setTimer, and we'll call the shooting end event. And instead of 1000 milliseconds, which is 1 second, I'll do 250 milliseconds. So this is 1/4 of a second. And we're going to repeat this event once. And here I'm going to do if not self.shooting and place this inside. So when the player presses on the X key, we're going to make a check so that we're not firing bullets continuously until we set shooting back to false. And that is going to be done over here in our game loop. So here I'm going to do elif event.type is equal to shooting end Then we'll do player.shooting, and we'll set it back to false. So now let's save and run the program. Alright, so now Megaman is going to fire bullets if I press on the X key. And you can see we only fire one bullet. And if I hold on to the key, you can see we are firing fewer bullets, and we are firing them every quarter of a second. Okay, so there's some interval in between bullets. Alright, so now the next thing I want to do is have the bullets collide with the metal enemy and destroy the enemy. So let's go ahead and implement that. And one thing about bullets is we can only use them once. So here I'll add another field called used. And by default, this is going to be false. So once the bullet collides with a metal enemy, that bullet is now used. Alright, so let's scroll down to the metal class. And over here, we're going to add another parameter. And this is going to be self.health. And we'll set it to 1. So these enemies are weak. They only have 1 health, so if you fire 1 bullet at them, they will be destroyed. Of course, for your game, you can change this value if you like, and the reason why I don't have a max health here is because the metals cannot recover. Alright, so let's make the bullets damage the metal. So here, I'm going to scroll down to our move function, and where we iterate through all the bullets, I'll make a check for metal in metals if metal.health is greater than 0. So if this metal is still alive, and not bullet.used, so this bullet has not been used, and bullet.collide rect metal, we're going to deduct 1 point from metal health. So metal.health minus equal 1, and we'll make the bullet used. So we'll set this to true. Alright, so this is going to destroy the enemy, but we need to remove the enemies from the list as well as the bullets once they're used so that we don't draw them. So here I'm going to do player.bullets, and I'm going to use something called list comprehension. And if you don't know what that is, I have a few videos on list comprehension on my YouTube channel, so if you want to check that out. But basically, a list comprehension allows us to create a list with values using a for loop in a single line. So here, the syntax will be bullet for bullet in player.bullets, if not bullet.used. So this is creating a new list and copying over all the objects from the previous list under a certain condition, which is if the bullet is not used. So if we were to write this using a for loop, it would look something like this. So here you can see we would need to create a new list, iterate through all the bullets, make a check to see if the bullet is used or not, and then we append this bullet to the new list and reassign it back to player.bullets. So we can do all of this in one line. So this is the appending part, this is the for loop, and this is the condition. And the best part is we don't need to create another variable. Alright, so this is going to clear all the used bullets, and let's do the same for the metals. So for this list, we're going to do metal for metal in metals if metal.health is greater than 0. So if the metal health is greater than 0, that means it's still alive and it has not been destroyed yet. And of course, since this is a variable, we need to add a global declaration because metals is a global variable. And if we don't add that global declaration, then it's going to be treated as a local variable. So over here, I'm going to do global metals. So any reference to this metals variable inside this function is going to refer to the global variable. All right, let's save and run the program. Okay, so we have megaman here, and I'm going to fire a bullet, and we destroy that metal. Fire another bullet, and the metal is also destroyed, and one more, and there you go. So we can now destroy the metals with our bullets. Now, there's one issue that I want to address, and that is when I fire bullets, since these bullets are not hitting any enemy, they're just going to travel forever off screen. And this is going to accumulate in our bullet list. So just to show you what I mean, I'm going to scroll all the way down, and over here, I'm going to add a print statement. So print length of player.bullets. And if I save and run the program, you can see I fire once, we had one bullet, and the bullet destroyed the metal, so now we have 0. Now, if I keep firing, you can see these bullets go nowhere. and we are just accumulating more and more every time. And of course, if you're playing a video game like this, you're going to be shooting a lot of bullets, and these bullets might not target any enemy. And because we are iterating through all the bullets, if I had 1,000 bullets, then we're going to have to iterate through the bullets 1,000 times. So if I had 10 metalls and we have 1,000 bullets, even though those bullets will never be able to hit these metalls, we are still checking for them. So this is going to multiply very quickly, so we need to do a cleanup. Fortunately, we are already doing a cleanup for used bullets. So I'm going to expand on this conditional statement, and since we have a lot of code on this line, I'm going to use a backslash, and now I can continue my conditional statement on a new line. So this is something useful that we can use in Python. So here I'll do and bullet.x plus bullet.width. So this is the right side of the bullet. If the right side of the bullet is greater than 0, that means the right side of the bullet is on the right side of the left boundary of our screen. And we also want to check the right boundary. So here I'll do and bullet.x is less than game width. So the left side of the bullet is to the left of the right boundary of our screen. So once the right side of the bullet completely goes off screen, we will not include it in our bullets. Alright, so let's save and run the program. Alright, so now if I continuously fire bullets, you can see the bullets decrease. And we only have one bullet now. So it doesn't matter how many I fire. As soon as the bullet goes off screen, we clear it, okay? Alright, so over here, I'm just going to comment this out again, and I'm going to save and run the program one more time. Alright, so now I can shoot the enemies like so, and now we have no more metalls. Now, one more thing I want to show you before I end the video, and that is what happens if the metal has more than 1 health. And you can see we deduct 1 point every time for metal health. So if metal has more health, let's say 5, then it would take 5 bullets to destroy the metal. So let's save and run the program. So I have a metal in front of me. I'm going to fire once, twice, 3 times, 4 times, 5 times. Okay? 1, 2, 3, 4, 5. And of course, if I touch the metal, I take damage. And if I'm away, I can shoot bullets. So 1, 2, 3, 4, 5. All right? So I'm just going to change this back to 1. And that is because in the Mega Man games, metal can defend and fire bullets. So for that reason, the metal only has 1 health. Alright, so that's it for this video. Hopefully you found this video helpful. And in the next video, I'm going to have metal change directions to face the direction that Mega Man is in. So if Mega Man moves to the right of metal, then we'll have metal face to the right. And we're going to implement 2 more features in the later videos. One is shooting bullets, and the other is guarding or defending. So if metal is defending or guarding, then the bullets do nothing and cannot destroy the metal. So yeah, that's it for this video. If you found this video helpful, make sure you give this video a like. If you have any questions, let me know down below in the comments. And if you want to stay up to date for more Python game programming tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.